Hey friends, here we are in another lesson. What we're going to look at in this one is known as the product rule. So we know in mathematics that the product means we're going to multiply two things together. So our goal today is to learn how to take the derivative of two things, two functions that are multiplied together. So we could call this, say, h at x is equal to f at x times g at x. So how do we take the derivative of a product? All right, good news is it's pretty easy. What I'm going to do here is, again, I'm just going to go ahead and just give you the rule, and you'll just have to blindly trust that I'm telling you the truth. I am most of the time, and you'll just have to follow it. Okay, I'd like to do an investigation, but videos, let's get to the point. Okay, here we go. What this says is we've got f at x times g at x, and you see the prime, so we want the derivative of this. Here's how this goes. It goes like this. It's the first function, just as it was, multiplied by the derivative of the second, plus the second function times the derivative of the first. I'll say that again. It looks kind of ugly, but it's easy with words. It's first times the derivative of the second plus the second times the derivative of the first. Okay? As long as you know that expression, you've always got this. Now, some people write it the other way around because it's an addition, and you certainly could. Okay? Don't panic about that. It's just a different way to write it. Let's try this, friends. Let's just try two examples. You'll see how easy this is. So the first one here, we could definitely distribute the trinomial to the binomial and make a big new function, but why do I want to do that? I don't want to do that. So here's what we're going to say. We're going to go and call the first one f at x and the second one g at x. So here's what I do. I'm going to say, what's the derivative of f at x? So f prime is 2x minus 3. What's the derivative of g? G prime at x is 5x4. So now that I know these two pieces, and you don't have to do them individually like this, but I like to when I'm first learning this. So now let's take the derivative. It's the first, so f at x, times the derivative of the second, 5x4, plus the second, g at x, times the derivative of the first, 2x minus 3. That's it, friends. That's the product rule. But now what I want you to think about here is, in the end, is there a way to simplify? Is there anything we can factor out of this big beast? On this one, there isn't, but on some questions, we're going to find there is. So I always need you looking to see if you can simplify at the end, if you can factor. Otherwise, we're going to leave it just like that. Not so bad, eh? Okay, let's try another one here. Now, I haven't left myself enough room because I'm not that smart. So let's just rewrite this one down here. Let's go black. So we are going to take the product rule on this guy. So what you again want to think about is, let's call f at x is equal to root x. And you might want to write that as x to the 1/2. So f prime at x, the derivative, is 1/2 x to the -1/2. G at x is the second function. So 5 minus x to the 1/2. So g prime at x is simply -1/2 x to the -1/2. So when you're first learning, if you like this, figure out your derivatives off to the side and then just put it together. Your derivative is the first times the derivative of the second plus the second times the derivative of the first. And now, friends, all you got to do is just go and plunk all the pieces in, right? Substitute them in. So if I've got the derivatives taken, look at, I just go and substitute them into my formula. Just like that. Lost the negative there. On this one, we're able to do some factoring. And this is where students actually struggle with the product rule. It's not with the product rule itself, it's with the simplification of this thing. So what I'm going to do first is I'm going to do some factoring. So what I notice I can factor out is I see that and that. So what I'm going to factor out of this is I'm going to factor out negative 1/2 x to the negative 1/2. What do I have left? X to the 1/2. And then I'm going to factor a negative out of that last one. So that's going to make this a negative here. And 5 minus x to the 1/2. So let's keep simplifying. So what I'm noticing now is inside my brackets there, well, this is going to be x to the 1/2 plus x to the 1/2. So that's 2x to the 1/2 minus 5. All right. Well, let's simplify a little bit more. I don't like to write things with negative exponents. So let's rewrite this. Here's 2x to the 1/2. And what about that negative that we had there? Well, I'm going to put that negative just like that. Or I could write this like this. If you'd like, I could distribute that negative in, which sometimes they do. And sometimes, again, they'll rewrite it as a radical, like that. Okay. Either way, these are both acceptable, but it's just that simplification at the end. So when you're simplifying at the end, I want you to look to see if you can do some factoring. That's it, friends. The product rule. The first times the derivative of the second plus the second times the derivative of the first.